students. Now we are starting chapter 6, applications of vector algebra. So let us recall the 11th standard portion, dot product and the cross product. So dot product is also called scalar product. So the definition of the dot product, a vector dot b vector is equal to modulus of a vector modulus of b vector cos theta. So in terms of components, the dot product can be written as a vector dot b vector is equal to a1 b1 plus a2 b2 plus a3 b3 if your a vector is equal to a1 I cap plus a2 j cap plus a3 k cap and b vector is equal to b1 I cap plus b2 j cap plus b3 k cap. So the a vector and b vector is given. If you want to take the dot product between them, so what you have to do? You have to multiply the same components because I vector dot I vector is 1. So you have to multiply a1 into b1 plus j dot j is 1. So a2 b2 plus k dot k is 1. So a3 b3. Next we are moving to the cross product. Is also called vector product. So the definition is a vector cross b vector is equal to modulus of a vector modulus of b vector sin theta n cap. So n cap is the unit vector which is perpendicular to a vector and b vector. So in terms of components, how the cross product can be written, it is equal to the determinant. In the first row you have to write I, j, k. In the second row, you have to write the components of first vector. In the third row, you have to write the components of the second vector. Okay. So now, we are coming to the 12th standard topic. Application of dot and cross products in trigonometry. Okay. I'll take the first problem, exercise 6.1, 9th problem. Using vector method, prove that cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. This result you have studied in 11th standard in trigonometry. Now we are going to prove the same result using dot and cross product. Okay. So for that, so we have to take the two vectors a cap and b cap. A cap is equal to OA vector and B cap is equal to OB vector. Okay, they are unit vectors. So, and making those OA and OB making angles alpha and beta with the positive x-axis. That means this OA vector make angle alpha with the positive x-axis. The same way OB vector makes angle beta with the positive direction of x-axis. Okay. So see now, if alpha cos of alpha minus beta. So here alpha minus beta is given. You have to take A and B both the points in the first quadrant. Okay. So next one. What we are going to do? We are going to draw the perpendiculars AL and BM to x-axis. Now you are having the triangle OLA. It is a right angle triangle. So here you are having 90 degree. So consider the triangle OLA. It is a right angle triangle. In this triangle you are going to find cos alpha. So cos alpha means it is the adjacent side by hypotenuse. So what is the adjacent side? You consider this triangle. So here the angle made is alpha. What is the adjacent side? Adjacent side is OL. What is the hypotenuse? This angle is 90 degrees. So the opposite side is nothing but the hypotenuse. So OA is the hypotenuse. So cos alpha is equal to OL by OA. Okay, in the same triangle, you are going to find sin alpha. Sin alpha is what? Opposite side by hypotenuse. What is the opposite side? AL. Okay, so otherwise you can write LA because we are considering here only the length, okay, not the vector. So LA by OA. See that in the starting itself I have told OA vector is a unit vector. So unit vector means whose magnitude is 1. So OA, the length OA is equal to 1. In the same way the length OB is also 1. So here in the place of OA it should be 1. Here also 1. So you are getting cos alpha is equal to OL and sin alpha is equal to LA or AL, because we are here we are representing we are only the length. Okay. So in the same way consider the next triangle OMB. This also a right angle triangle. Okay. So what is cos beta? Here the angle made is beta. So cos beta is equal to OM by OB. You know, this is the adjacent side, this is the hypotenuse. Sin beta is what? Opposite side. That is MB or BM. Okay. Divided by OB. Here I have written cos beta and sin beta. Here also OB is also, it is whose length is 1. Okay. So here also 1. So cos beta and sin beta you have found. Now the same triangle OLA triangle you just consider, and you are going to write OA vector using triangle of addition of vectors. Using triangle law of addition of vectors, OA vector can be written as OL vector plus LA vector. So here I am using vectors. So while you are using vectors, you have to be careful in magnitude. So OA vector can be written as OL vector plus LA vector. Okay, you have to start with O and you have to end with A. So using triangle of addition of vectors, OA vector can be written as OL vector plus LA vector. You see that? But now we have to write the OL vector. So any vector can be written as whose first you have to write the magnitude and you have to write the unit vector acting along that vector. So here what is the magnitude of OL? Here we have found the length of OL is cos alpha. So here I have written the magnitude. You look at your OL. So OL is on the x-axis. So I cap is the unit vector acting along x-axis. So magnitude into the unit vector, that is cos alpha into I cap, is nothing but OL vector. In the same way you have to mention LA vector. So what is the magnitude of LA? That is sin alpha. You look at your LA, here you have to be careful with the direction LA. So it is parallel to y-axis. In y-axis, which vector is acting? J vector, that is the unit vector. J vector is the unit vector acting along y-axis. So here your LA vector can be written as the magnitude sin alpha into J cap. So you are getting OA vector like this. In the same way, consider the next triangle. Here you are going to write OB vector. So how you have to start with O and you have to end with B using triangle of addition of vector. So it is OM vector plus MB vector. Here I have written. So here you have to write the magnitude and the unit vector. So OM vector, what is the magnitude of OM? It is cos beta. Cos beta. OM where it is? It is on the x-axis. So I cap is the unit vector acting along x-axis. So cos beta into I cap. Come to MB vector. So MB vector is also parallel to y-axis. J vector is the unit vector acting along y-axis. So it is sin B J vector, J cap. Okay. So now the angle between A cap and B cap, what is it? A cap is here and B cap is here. What is the angle made? It is alpha minus beta. The whole angle is alpha. This is beta. When beta is subtracted from alpha, this is your alpha minus beta. So the angle between A cap and B cap is alpha minus beta. Okay. So here I am going to take a dot product. Why I am going to take dot product means here the question is cos of alpha minus beta. So by the definition of the dot product, so here which trigonometry function is involved in dot product? Cos theta. So if the question is asked cos alpha minus beta or cos alpha plus beta, if cos comes, you have to take the dot product. Okay, suppose sin alpha minus beta, sin alpha plus beta comes, you have to use the cross product, because cross product, which trigonometry function is used? Sin theta. So here my question is cos of alpha minus beta, so you have to take the dot product between a cap and b cap. Okay, what is the definition of dot product? I have said modulus of a vector, modulus of b vector, cos theta. So in the same way, modulus of a cap, modulus of b cap, cos of what? Theta. What is the angle between a cap and b cap? It is alpha minus beta. So I have written cos of alpha minus beta. You see that? What is modulus of a cap? A cap we have taken as a unit vector. So whose length, magnitude means whose length is 1. Here also 1. So the answer is cos alpha minus beta. Okay. So next the same thing I am going to write in terms of components. Okay. So a cap I have written in terms of components and the b cap also in the same way. In between you are having dot product. So while I am in the starting, how to take the dot product in terms of components? You have to multiply the same components and then add. So in the same way, you see that I cap dot I cap is equal to 1. So cos alpha into cos beta plus sin alpha into sin beta. Look at the first one. First equation, the left side, what you are having? A cap dot b cap. In the second equation, left side, what you are having? A cap dot b cap. So therefore they are equal. So equate the right hand side. In the right hand side, what here you are having? Cos of alpha minus beta. So therefore cos of alpha minus beta is equal to, here the right hand side you are having cos alpha cos beta plus sin alpha sin beta. So using dot product we have proved the trigonometry result. Okay. In the same way, you see the example 6.3. So here you are having cos alpha plus beta. You see that the previous problem, cos alpha minus beta. The previous problem, cos alpha minus beta. So if alpha minus beta comes, you have to take A and B in the first quadrant. Like this you have to take. Okay. Here alpha plus beta comes. So the angle alpha plus beta comes, you have to take one point in the first quadrant and the next point in the fourth quadrant. Okay. So see that is the very important. If you change the problem, whole problem will be wrong. So you have to be careful when seeing alpha minus beta means both the points has to be taken in the first quadrant. If alpha plus beta means one point in the first quadrant and the next point in the fourth quadrant. Okay. So the same thing we have to proceed. So the A vector and B vector or unit vectors, they make angles alpha beta with the x-axis, and using the triangle, what is the triangle? OAL, you have to find cos alpha sin alpha. In the same way, in the next triangle OMB, you have to find cos alpha, cos beta and sin beta. The same thing you have to proceed. Already I have explained. Now you consider the triangle OA vector. How it will be written? As usual, using triangle of addition of vectors, OL vector plus LA vector. OL vector plus LA vector. OL vector, while you are writing, you have to consider the magnitude. OL oda magnitude is cos alpha and OL is in the acting on the x-axis. So the OL is on the x-axis. So you into I cap. Okay. In the same way, look at your LA vector. Vector while you are writing, you have to see the direction. So LA vector while you are writing, first you have to write the magnitude. The length of LA that is AL, both are same lengthwise, so it is sin alpha I have written. How is your LA? It is parallel to y-axis, so you have to write the unit vector on the y-axis is j cap. Okay, coming to the same thing, coming to the next one, OB vector. OB vector, how it will be written? OM vector plus MB vector. OM vector plus MB vector. OM vector, how it will be written? What is the magnitude of OM? It is cos beta. Okay, and OM is on the x-axis. So I have the unit vector I have written here, it is I cap. Come to here, MB vector. So MB vector, you see the direction MB vector, which is also parallel to y-axis, but you see that j cap is acting upward, your MB vector is acting downward, but the direction is changed. So here you have to mention minus j cap. This step is very, very important. So plus into minus is minus. So your OB vector is like this. Okay, what is the angle between them? So this is your alpha, this is A cap and this is your B cap. What is the angle between them? The whole angle. What is it? Alpha plus beta. Okay, so again you have to see the question. What is the question? Cos of alpha plus beta. Cos comes, you have to take the dot product. So the dot product of A vector and B vector, you have to use the definition. So what is it? Modulus of A vector, modulus of B vector, cos theta. Your theta is alpha plus beta. So this is 1, this also 1. So your answer is cos alpha plus beta. The next one you have to say write the in terms of components. So I have written in terms of component A cap and B cap. You have to take the dot product. So same components has to be multiplied. Cos alpha into cos beta. Plus into minus is what? Minus sin alpha into sin beta. So while equating 1 and 2, you will get cos alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. So next one, we are moving to exercise 6.1, 10th problem. So see the question, sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. So the first thing what you have to see, it is alpha plus beta or alpha minus beta. It is alpha plus beta. So if alpha plus beta comes, you have to take one point in the first quadrant, another point in the fourth quadrant. Okay, so the same thing has to be considered. Okay, see, here I have found cos alpha. So here I have found cos alpha, sin alpha and cos beta, sin beta. Now I am coming to OA vector. OA vector, how it will be? Using triangle of addition of vector, OL vector plus LA vector. Okay, and it is cos alpha I cap plus LA vector, how it is? Both are parallel as well as j vector is acting upward. Here also it is another here j vector, they are parallel, so here you can mention j vector. Okay, coming to OB vector, it is OB vector can be written as OM vector plus MB vector. So MB vector is acting downwards, in j cap is acting upward, so the direction has changed. So here you have to mention minus j cap, that is the important one. So B cap is equal to cos beta I cap minus sin beta j cap. Just come to what is the angle between A cap and B cap. You see that this is your A cap and this is your B cap. So the angle between them is alpha plus beta. You see now. Here the question is what? Sin alpha plus beta. If sin theta comes, you have to use the cross product. While you are using the cross product, you have to take B cap cross A cap. Okay, you can take B cap cross A cap. Use the definition of cross product. What is the definition of cross product? It is modulus of A vector, modulus of B vector, sin theta n cap. Okay, so come to here, it is a modulus of B cap, modulus of A cap Sine. What is the angle between them? Alpha plus beta. So sine of alpha plus beta, and you have to write the unit vector which is perpendicular to B cap and A cap. So B cap and A cap. So which vector is perpendicular to this now? It is K cap. What is K cap? K cap is the unit vector acting along Z axis. So here B cap and A cap. So K cap is the unit vector acting perpendicular to B vector and A vector. So therefore here this is 1, here also 1. So it is sine alpha plus beta into K cap. So now in terms of components you have to write the cross product. How to write in terms of components the cross product? It is nothing but the determinant. In the first row you have to write ijk. In the second row what you have to write? Which vector comes first, whose coordinate has to be written in the second row. In the third row you have to write the components of the second vector. Come to now, here you have found B cap cross A cap. Here while here also the same thing has to be done. So B cap cross A cap is equal to determinant. What is it? I, J, K. In the second row which one has to be written? B cap, because this is the first one. So B cap. What is the components of B cap? Cos beta. And here minus sin beta. There is no K. So it will become 0. What is A cap? Come to the A cap, the I component is cos alpha and the J component is sin alpha, and K cap component no, so it is 0. So we have to expanding by R1. So see that I cap, delete the first row and the first column, 0 minus 0. Come to the, while you are moving to the second element you have to write minus. So it is minus J cap into, delete the first row and the second column. Cos beta into 0 was 0, minus cos alpha into 0 was 0, plus K cap, delete the first row and the third column, cos beta sin alpha. So sin alpha cos beta. So in the formula itself we have to write minus, here also one minus, so it will become plus cos alpha sin beta. So when you simplify, it is K cap into sin alpha cos beta plus cos alpha sin beta. From 1 and 2 you have to equate. So when you cancel K cap you will get the result what we want. Sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. Okay, coming to the next one. So it's an example. You look at this. Here you are having alpha minus beta. So what you have to do? You have to take both the points in the first quadrant. So this is your alpha and this is your beta. So when you subtract, this angle is alpha minus beta. Okay. So see now you have to go for the cos alpha, sin alpha, cos beta, sin beta you have to find, and OA vector how it will be written? OL vector plus LA vector. So everything in the first quadrant, so they are acting parallel to y axis, everything direction is upward. Everything will become plus. The same way B cap. So here next, after finding A cap and B cap, you have to see the question what is asked. So it is sin alpha minus beta. So if it is sin alpha minus beta, sin comes, you have to use a cross product. While you are using cross product, B cap cross A cap you can use. Okay, if you use A cap cross B cap, here it should be minus. To avoid minus, I have taken B cap cross A cap. So that is equal to modulus of B cap, modulus of A cap, sin alpha minus beta into K cap. So these two results are 1 into 1. So you will get. So you have to use the components while you are expanding by R1. So by R1 you will get this result. So from 1 and 2 if you equate, you will get sin alpha minus beta into K cap is equal to sin alpha cos beta minus cos alpha sin beta into K cap. So K cap getting cancelled. So you will get the result. So listen, alpha minus beta comes both the points should be in the first quadrant. If alpha plus beta comes, one point in the first quadrant and the next point in the fourth quadrant. If cos comes, you have to use the dot product. If sine comes, you have to use the cross product. These are the points you have to remember to work out this problem. Thank you, students.